Hello guys, welcome to another online lectures. Today we are going to look at what we call phylogenetic tree. Now phylogenetic tree is a very useful terminology in biology. Now basically what we mean when we say phylogenetic tree, we mean a tree that will show the ancestral relationship between groups of organisms or group of species that are under your studies. Now considering that let's say you are studying on bacteria. You are studying on bacteria. Now, in this bacteria, you have different species of bacteria. Let's say this one is E. coli, and this one will be Proteo alpha bacteria, and let's say this one will be cyanobacteria. Now, let's say you want to find out the ancestral relationship between these three bacterial types. So you need to refer to yourself to the phylogenetic tree in order to be able to know which of these species of bacteria is the ancestral one and which one is the more recent diverged lineage. So in trying to find out that, you need to draw a tree, a kind of a family pedigree that will show you the relationship between them. So in knowing the phylogenetic tree of a group of organisms under your studies, you also know which one is the ancestral species and which one just diverged more recently and which one are the middle diverged groups. So here, basically what we do is we try to construct a tree based on your the type of molecular marker that you are using. Now suppose you are studying these types of studies by using the mitochondrial DNA of this species. Now the first thing that you need to do is you need to be able to isolate your mitochondrial DNA. Now you need to extract your mitochondrial DNA from the total genome of all these organisms. And now after you isolate your mitochondrial DNA, you try to amplify this mitochondrial DNA through the use of polymerase chain reaction (PCR). So when you do that, then you are now going to send that PCR product into companies for sequencing for you to be able to know the nucleotides, the amount of mutations that happens with time. That is the substitution or the deletion or the inversions that happen during the course of time. And in doing that, you need some program, some computer programs that we use in phylogenetics. So when you have your results, suppose your result shows to you that E. coli was the oldest species, and followed by, let's say, alpha proteobacteria second, and the third one is cyanobacteria. Now suppose you want to construct your phylogenetic tree in these three species of bacteria. What we're going to do is, since we know that E. coli is the ancestral species and it is from which the second and then the third species, which is alpha proteobacteria and cyanobacteria respectively, diverged, what we're going to do is first consider we have a root of the tree, just like every other tree. So here we are going to have our E. coli. We're going to put our E. coli here so that it will be the ancestral father. And you know that alpha proteobacteria diverged from E. coli before the cyanobacteria. We're gonna have a branch here, and this branch, we're gonna donate this branch to represent alpha proteobacteria. And after that, what we're gonna do here is we're gonna be able to make another branch here to be able to represent the cyanobacteria here, to be able to represent the cyanobacteria here. So in that case, this is what we call the phylogenetic tree. You see that it is a kind of a tree, and what does it explains to you? It explains the relationship, the ancestral relationships between groups of organisms that you are studying. So this is a very important tool if you are dealing with phylogenetics, if you are dealing with phylogeography, and even if you are dealing with molecular biology, you need to know what phylogenetic tree is. Since at the end of your research, you will need to explain to the people the relationship of the groups of organisms that you have done your research on. So I hope it is fully explained, phylogenetic tree, and we can use different molecular markers, different organelles to study these things. And most of the times we try to use the organelles that all the groups of organisms under your studies they shared. Like ribosome is a very good marker to use to be able to find a resolution, a connection, or an ancestral history between the groups of organisms. You can use the mitochondrial DNA since it has just what we call a maternal inheritance. You can use ITS, which is from the nuclear genome. You can use that one as well. So phylogenetic tree, it is a tree that explains or shows the relationship between groups of organisms that are under your studies. I hope it is going to explain. Feel free to get back to me via my YouTube channel or via my regular email address that you can access at my YouTube channel, and I shall get back to you. Enjoy the video. Thank you.